Welcome. In this video I am going to talk about exact differential equation. So let's start. First of all, let us understand what is the meaning of an exact differential equation. So a differential equation m dx plus n dy is equal to 0 is said to be exact if this expression is equal to the exact differential of some function. It means what? It means that this expression can be written as differential of some function of x and y. To understand this, let us take a very simple example. Suppose we have something like y dx plus x dy is equal to 0. Now you can see that both of them look like the similar expression. In place of m we have y and in place of n we have x. So what I was suggesting is that can you write this expression as d of something? If you can write this expression as d of something, this will become exact differential equation. So in our calculus class we might have studied that if you remember what is d of xy. So d of xy is you take x and then you differentiate y, so x dy, and then you take y and you take the differential of x. So here you can see that this expression is nothing but d of xy. So since this expression can be written as differential of xy, so this differential equation will be an exact differential equation. And how to solve it? To solve it, you just integrate both sides. So here d of xy will give you xy, and in the right hand side you will get the constant. So what you have got is the solution of this exact differential equation. Now it is a very simple or trivial kind of example, and in most of the problem you will note that you will come across some complicated expression, and it won't be that much easy for you to realize that the expression is the exact differential of something. So for that we have an alternate approach. What is that alternate approach? That to decide m dx plus n dy is equal to 0, whether it is an exact differential or not, so we first calculate del m by del y and we calculate del n by del x. Here this is the partial derivative of m with respect to y, and this is the partial derivative of n with respect to x, and if both of them are equal, then we say that the given differential equation is exact. So once we have got that it is exact, the next step is to check how to solve it. So to solve it, what we do, we take m and we integrate it with respect to x by keeping y as constant, and then we integrate those terms of n. It is important. In the second integral, we consider only those terms of n which does not contain. So x should not be present in those terms. We only take those terms and then we integrate it with respect to y. To make more sense of it, let us take this example. So as you can clearly see that this expression is m dx and this is something like n dy is equal to 0. So first of all, let us write m and n separately. So here m is y square e to the power xy square plus 4x cube, and what is n? N here is 2xy e to the power xy square minus 3y square. So first we calculate del m by del y. So I hope you know how to differentiate partially. The second term is x cube, 4x cube, so it will be constant and it will give me 0. So we just have to focus on the first term. So I take y square, I take del by del y of e to the power xy square. We are using a product rule, and then e to the power xy square and del by del y of y square. So if I complete it, y square as such, e to the power xy square will give me e to the power xy square, then xy square will give me x and into 2y. I hope you know how to differentiate, and plus from here I will get 2y, so I can write 2y e to the power xy square. So just to make it look better, or just to simplify, I can write 2xy cube into e to the power xy square plus 2y e to the power xy square. Now next thing is we have to find del n by del x. So Again this term will give me 0. I will take the first expression, that is 2xy e to the power xy square. So here we take 2y constant, right, and we have x as the first function and e to the power xy square as the second function. So I take x e to the power xy square into y square and plus e to the power xy square, and derivative of x will be 1. So you can clearly see that we are getting the same thing here, x y square and 2y. So it will be giving 2x y cube into e to the power xy square and plus 2y e to the power xy square. So you can clearly see that del m by del y is equal to del n by del x. So it means what? That the differential equation is exact. So this is the first step to decide that whether the differential equation is exact or not. What is the next step? The next step is to solve it. So to solve, I already have copied the original differential equation here so that we don't have to go back again and again. So here we have got that this is an exact differential equation. So the next step is to solve it. So we can write the solution. So the solution is given by, and what is the expression? You take m, means we take this whole thing, y square e to the power xy square plus 4x cube, and we have to integrate it with respect to x, but in this we have to keep the y as constant. And in the second term we have actually in n we have two terms, this is first and this is second. But in the first you can see we have x also, so we don't have to take, you see the expression, we just have to take those terms which does not contain x. So in this there are two terms, that is 2xy e to the power xy square. So it contains x, so we should not take it, we should take only the second term. So second term is minus 3y square, and then we integrate it with respect to y, and this is equal to constant. Some students will make the mistake, they will just take 3y square. So don't make, you have to take minus 3y square here. Now I hope you know how to integrate. So because we have to keep y square as constant, so y square will come out of integration sign. E to the power xy square will give me e to the power xy square, and divided by because we are treating y square as a constant, so I have to divide it by y square, and plus 4 x cube will give me x to the power 4 by 4, and minus 3 y square will give me y cube by 3, and that is equal to constant. So this 4 and this 4 cancel, this 3 and this 3 cancel, this y square and this y square cancel. So what we have got? We have got the final answer, that is e to the power xy square plus x to the power 4 minus y cube is equal to c, and this is our solution. This is our solution. So this is the first problem. I am going to solve few more so that it is absolutely clear to you that what is the process of solution. Now let us solve this problem here. So in this we are not going to spend too much time. I will quickly write m. So what is m here? X square plus y square minus a square, and don't miss to write this x also. And what is n here? So n here is x square minus y square minus b square and into y. So what is the first thing? We have to check whether it is exact or not. So I will take del m by del y, not del x, right? So del m by del y. So because we have to integrate it with respect, differentiate it with respect to y, so x is a constant, I take x. X square will give me 0, y square will give me 2y, and a square will give me 0. So we just get simply 2xy. Similarly, if I have to find del n by del x, here the y is constant and I have to differentiate this expression in the bracket. So x square will give me 2x, y square will give me 0, b square will give me 0. So this is also 2xy. So what did I notice? I noticed that del m by del y is equal to del n by del x, and since they are equal, so this differential equation is exact. So once we have verified that it is exact, we have to write the solution. So how to write the solution? The solution is, I write the solution is, what we do, we integrate m. So m is what? M is x cube plus xy square minus a square x. I hope you got. We have x here, so I multiplied it so that it is clear to you, and we have to keep the other term, that is y, as constant. And in n we have to take only those terms which does not contain x. So you take x square into y? No, because it contains x. Can you take this minus y cube? Yes, you can take. And then minus b square y, and then dy, and this is equal to constant. Now let us further solve it. So x cube will give me x to the power 4 by 4, xy square, but since y square is constant, I write y square and x square by 2, and minus a square, integration of x will give me x square by 2. In the next we have minus y cube, so it will give me minus y to the power 4 by 4, and minus b square, and y will give me y square by 2, and the whole thing is equal to constant. This can be left as the solution, but since we know we want to make the things look beautiful, yes or no, beauty should be appreciated. So to make it look better, what we can do, we can multiply the whole expression by 4. So I will get x to the power 4, and here I will get 2 times x square y square. Here I will get 2 times a square x square minus y to the power 4, and minus 2 times b square y square, and is equal to 2c. So for 2c I write another constant, that is k, where k is equal to 2c. So what I have got is the solution for this differential equation. I hope it is making sense to you. So let us solve few more. So in this, what is m? Now I hope you are smart enough to write it directly. M is equal to 2x by y cube. And what is n? So n here is y square minus 3x square by y to the power 4. Just for your convenience, you can write it 1 by y square minus 3x square by y square. I hope you got it. I separated y square by y to the power 4, and so on. Now what is del m by del y? So we have to differentiate it partially with respect to y. 2x is a constant. 1 by y cube means y to the power minus 3. So I will get minus 3 by y to the power 4. So it is minus 6x by y to the power 4. And what is del n by del x? So minus 3x square, it will give me minus 6x by y square. Yes or no? I think there is some mistake I have made, because it should be equal. Yeah, I have made a mistake, which you can see. The mistake that I have made here is that I should be writing y to the power 4 here. Yes or no? And here also I will get y to the power 4. So the maths has a beautiful nature that most of the time when you make a mistake you realize. So you have got the same thing, del m by del y is equal to del n by del x. So I can write that del m by del y is equal to del n by del x. So the differential equation is exact. Now how to solve it? So I can write the solution. So the solution is, and what will be the solution? Can we change the color? So the solution is, we have to take the m term, that is 2x by y cube, and we have to integrate with respect to x. We have to keep the y as constant, and in the second term we have 1 by y square, and we have this, but we don't have to consider this because it contains x. So I just have to take plus 1 by y square dy, and the whole thing is equal to c. So if I integrate, what I will get? 1 by y cube is a constant, and integration of 2x will give me x square, and integration of 1 by y square will give me minus 1 by y. So that is equal to c. So the correct answer here is x square by y cube minus 1 by y is equal to c, and this is your answer. If you want to write it further, you can simplify, take the LCM and on, but I think it is good enough. Okay, so I hope you are getting the process of solving the exact differential equation. Let us solve one more question so that the things are absolutely clear. So we have another question here, and it looks slightly complicated, but it is not. We can do the same thing. We identify what is m. So m here is 2xy plus y minus tan y, and what is n? So n here is x square minus x tan square y plus sec square y. So what is the first thing? We have to find del m by del y. So 2x, if I differentiate it, plus 1, and d by dy of tan y, so minus sec square y, right? And what is del n by del x? So here I will get 2x from this term and minus x, so tan square y is a constant, so minus tan square y, and del x by del x will become 1, and sec square y will again give me 0. Let me write it better. So here we have tan square y. So did you notice this term does not look like this term, but do you think that they are equal? In your trigonometry class you must have studied this result, that sec square x, here I am writing y, so sec square y minus tan square y is equal to 1, and here we have 1 minus sec square y. So you can see that I can write 1 minus sec square y is equal to minus tan square y. If I take the sec square y in the right hand side, I will get minus tan square y. So this 1 minus sec square y and minus tan square y are basically the same thing. So even though it does not look equal, but they are equal. So we can now conclude that del m by del y is equal to del n by del x, and so the differential equation is exact. And once we have got that this is exact, the next step is to write the solution. So writing the solution is very simple. The solution is given by what? We take all the terms in m. So in m we have 2xy, we have y, and we have minus tan y, right? And we have to differentiate it with respect to x, but we have to keep the y variable as constant, right? And plus, in the second we have to take only those terms which does not contain x. So x square, so there is x here. In the second also there is x here. So we have just one term, that is sec square y, which does not contain any x. So sec square y dy. So I hope you all know how to integrate. So we have to take 2y constant, integration of x will be x square by 2, then y constant, so it will give me xy, and minus tan y is also constant, so it will give me minus tan y, and into x, and derivative of sec square y is tan y, so that is equal to constant. So can we write the answer in slightly better form? Let me change the color so that it looks good. So I am writing the last step here. So x square y, and you have plus xy, and you have minus x tan y, and plus tan y, and the whole thing is equal to a constant, and this is your answer. So this is how exact differential equations are solved. We have explained the process, that what is exact differential equation. Before I end the video, let me quickly summarize the things. So the process is very simple, that whenever we have something like m dx plus n dy is equal to 0, what we do? We differentiate m partially with respect to y, we differentiate n partially with respect to x, we equate. If they are equal, it is exact, and once we have got that it is exact, we know how to write the solution. What we do? We integrate m with respect to x by keeping y as constant, and then we integrate only those terms. And here a student make mistake, that sometimes in the question the terms are written in such a way that they confuse you. So be clear that which term contain x, which term does not contain x. So separate them and take only those terms which does not contain x, integrate it with respect to y, and then write your solution. Okay, so that is all in this video. In the next video I will talk about the differential equation which are not exact but can be reduced to exact form by multiplying it by a suitable integrating factor. That will be a long video because there will be 5 different types of it. So that's all in this video. In case if you are new to the channel, subscribe it and do like the video, share with all your friends who are willing to learn mathematics. And in this channel you find good content, detailed content, so you must subscribe it. Thanks for watching. Have a great day.